Xcel Energy's In a Hard Hat Theater presents Damage Prevention, The Marks. Okay, you called the one call center, your crew is ready to go, now what? Now the locators kick into gear. We use paint and flags to identify the different utilities that may be buried at your work site. If you see red, there are electric power lines in the area. Yellow signifies gas, natural or propane. It could even be a steam or petroleum pipeline. Orange is all communications. That includes the phone companies and the cable companies. Blue is the water system, while purple paint marks signify reclaimed water, irrigation, or slurry lines. Finally, the green is used to identify the sewer and storm sewer lines. The American Public Works Association published standards for marking underground facilities in 2001. Let's take a quick look at what you might find in the field. Most often, the companies who own the lines will be identified on the flags used for that facility. When no flags are used, the name of the company should be placed along the painted route in abbreviated form. In this case, I marked it as Xcel Energy. When there are several lines in a trench, that should be indicated by the number of lines painted on the ground. This illustration could be 3 primaries, a 3-phase line, a single phase and 2 secondaries, or 3 secondaries. The point is that there are 3 separate sets of wires in the trench that you should be looking for. Fiber optics for the phone or cable company are generally marked with the letters FO, and a coaxial cable is marked as TV or CATV. When the locator is not sure of the number of lines in the trench or the number of conduits in the package, the corridor markings will be used. Remember, the 18-inch rule still applies from the outside of the marked facilities. Any pipe greater than 2 inches must be labeled with the size of the pipe. What does that mean for the crew on site? The pipe is 8 inches, so we start with that, and add 18 inches to both sides. We now have a hand dig only zone of 44 inches. Those really big utilities should be marked with these symbols. Again, we still have the 18 inches either side of the mark, so the complete hand dig zone in this illustration is 84 inches. For conduit packages, according to the APWA, these are the symbols to be used. Again, the 18-inch rule applies to both the outside edges. If the outside marks are 12 inches apart, our hand dig zone is now 48 inches. A service stubbed across the road or an end of a main will not look any different when marked in the field. It is still just the end of a pipeline. Marking offsets can be very helpful, especially in heavy construction areas. In this case, we have found a location to mark our phone line where the marks will likely stick around a while. It is 25 feet away from the actual facility. We identify which company we are marking, as well as the direction and distance to the facility. The locators should notify you when offset marks are used. Keep those lines of communication open. Remember to identify the pipe size if it is greater than 2 inches. In heavy traffic areas, you could also use marking whiskers to help maintain the location marking of the pipe.
How does locating work? Here's a super quick theory. Find what's underground before the excavator does. You need more than that? Well, then we need science. Understanding locating theory depends on an understanding of at least a few simple rules regarding the behavior of electricity. The key rule is that electricity and magnetism are linked. Wherever electricity is present, magnetic fields will also be present. Then there's alternating current, which creates a moving magnetic field. We call that a signal. The behavior of this magnetic field changes predictably with changes in the rate of the alternating current. We call that frequency. But what again is a signal? A signal is a moving magnetic field. As human beings, we rarely can sense and even less often experience magnetism. We can't see it, smell it, taste it, or feel it on our skin. Magnetism is invisible to all human detection. We can, however, feel and often see the effects of it. Add to the fact that utility locating relies on not just magnetism, but also on a moving magnetic field, and we have quite a challenge. So a signal isn't just invisible, it's on the move. And it's not slow either. The lowest frequency signal that any locator routinely deals with goes through a complete positive and negative phase, or one full cycle, 60 times each second. So what does that mean for us? We use electricity to create these magnetic fields, and then we locate those fields. Back to our first illustration. We create a field by creating an electric circuit. Now let's see if we can apply that knowledge. Grab your hard hat, let's go out in the field. Oh, you don't have your hard hat? Well, walk a mile with me in my hard hat. Don't worry, it only looks dirty.
Let's start by hooking up to a steel gas service. In order to create that magnetic field we call a signal on the pipe, we need to create a circuit with our transmitter. Okay, black wire to the temporary ground. Red wire to our target pipe. In this case, we hook directly to the steel riser. Powered up and ready to paint. Remember, all safety rules apply when working in the road. We are looking for the peak reading. We use yellow paint to signify gas is currently being marked. Always think safety for you, the public, and the facilities. Sometimes we can't access the tracer wire on a plastic service at the riser. In those instances, generally, we can get to the tracer wire in the service valves. Yep, we're tangled again. Red to target. Ground. No. Can't get a ground in. We need a ground. A little extra wire to get to the ground, and we are in business. Let's check out the signal. There is another wire in the valve. Now let's go play in traffic. When you are done, remember to put everything back to normal. Make sure it is safe. Remember that convenient concept? Meters aren't always in the most convenient locations either. How are you at climbing through jungles? Okay, so I added the sound effects. Aha! There it is. Round. Not a good one. Same concept though. Red to target, the tracer wire. This time we'll try the riser valve as our ground. This is not a good standard practice, but you can get out of a scrape in certain situations. How does that work? We have signal. Which is worse, climbing through the jungle to hook up, or going out onto the concrete jungle that we are about to enter? Yeah, don't mind the person standing in the middle of the road with equipment. Oh, wait. What about electric locating? Let's try a different hookup. This is an induction clamp. We still are looking for the peak signal. Wow, warmer than I thought. Same clamp hookup here. Can you see the old paint marks? They are very faint. See if you can spot the other old marks along this locate. Not every locate is that easy. Here's a head scratcher. Do you see the old marks? And the new mark? What's going on? Most often it has to do with the way we locate. We locate using a circuit, right? Most often that circuit uses a grounding system to move. What about the other utilities that are also grounding to the same locations? Grounds are at the house for a reason. Know when it is safe to disconnect the ground before you attempt this. Now, will that make a difference? If you disconnect the ground, make sure you reconnect them when you are done. Okay, a few pictures. First is in Elmwood. Primary goes south through the middle, with a service coming back north from the transformer, crossing the road to the west. Another service from the south goes to the east to the house. But we missed a service. Wait, there's another service that goes east along the lot line? Yep, it goes parallel to this service, feeding the house to the east. The only way we could know that is to check our maps. Sometimes things change after we install our wires. Here a subdivision has redesigned the property lines and has built a duplex on top of our secondary lines. Now our transformer sits in the middle of the new driveway. I have a feeling we will need to move that. Then again, the maps are not always enough. Here are maps showing underground service crossing a road. That's it. That is all the map shows. What do we find in the field? Let's start from the meter and wind our way back toward the road. Thank you for walking along with me. My name is R.C. Jensen. I'm a service technician for Xcel Energy in Menominee, Wisconsin. Next time you bring your hard hat, and together we will paint the town.